Hello, dear students. I am Professor Jayant Mane from Fintellix Academy, Ratnagiri. And here is the first lecture on electrical drives. And our first topic is Introduction to Electrical Drives. Now, as the name indicates, it's an electric drive. So, first we should get to know what is a drive. Any system which we use to give some motion or control the motion. So it is actually a drive. So some examples of drives. So right now I'm talking about some general drives, not in particular electrical drive. So any automobile engine is also a drive. In olden days, the steam engines were the drives, and even the bullock cart was having drive, isn't it? So everything which gives a motion and controls it the motion, then that system is a drive. So obviously, what is an electrical drive then? So this is also a system, just the difference is it runs on electric power, and obviously the motors runs on electric power, and therefore it is an electrical drive, called as an electrical drive. So if we see the definition of electrical drive, it is defined as a form of machine equipment designed to convert electrical energy into mechanical energy and provide electrical or electronic control of process. So that is what an electrical drive. So any real life examples if I want to give you, then the very simplest is the fan in your house, ceiling fan. So the ceiling fan is converting electrical energy into mechanical energy because there is a single phase induction motor connected in it. Then the fan experiences a load. Load is the windage, means the turbulence created in the wind around it. So it has to overcome that turbulence and it has to force the air downward. So that is what the load, which is called as that type of load is windage load. So that load is there on the fan. Then it also has a speed controller. So nowadays electronic speed controllers are available. So that is the controller of the fan. Obviously it is not electronically, you can say, a continuously controlled system, but still just to take the for sake of example, so when any human being is trying to control speed of the fan, so that also becomes part of the system. So in short, the human being experiences the airflow, or in other words senses the airflow, and accordingly the human being sets the speed of the fan by giving some motion to the knob by his hands. So in that case the human being becomes part of the system, in which his skin acts like a sensor, since it senses the flow of the air, and his brain compares that sensed air with the level of comfort of the body, and accordingly it senses the control signal through the hands. So accordingly it may be controlled, or it might have sent signal to hand to increase the speed or reduce the speed, and accordingly after doing that control action, again the brain senses the air flow and finally decides, once the speed reaches its desired, you can say, value or the comfort level is reached, then obviously the human being comes out of that loop, that control system. Any control system is like that. Just instead of human being, there are sensors to sense the output, then there are controllers to compare the output with some reference value and take the control decisions, and then the controllers which actually does the control action. And once the output is reached, in that case the loop becomes inactive. Just like in this case, the human being uh, just comes away from the control loop. So whenever there is, you can say, transient operation required, means starting of the fan, stopping the fan, or any speed change, in that case only the controller comes into picture. It acts, it gives some control action. Otherwise, whatever is the state of the fan, it remains same. Means if it is in off state and if controller doesn't do anything, then it remains off, or if it is in on state and controller doesn't do anything, then it is on and running with some steady speed. So for speed change also, the controller, the human being gives some command and then the speed is changed. Afterwards, if no further control action is given, no command is given, then the speed remains the same. So this is a very simple example of how any drive works in closed loop. So obviously it is a system. So system means it consists of various parts. So let's see the block diagram of the electrical drive. As you can see, there are few blocks connected through continuous lines, arrows, or discontinuous lines also. So first I should tell you that the blocks represents different parts of the system. Then the arrows shows the direction of flow of information or power. Then the continuous lines shows that there is some uh, there could be some physical, I can say, wiring. And when it is a discontinuous one, then it is actually part of control system. Sometimes this control system uh, might not have continuous connection or physical connection also. Sometimes it may be connected through some Wi-Fi or anything like that, or fiber optic or anything like that. Or even in other words, the power circuit and control circuits are also discriminated. The signals are discriminated using these types of lines. So obviously the sensor, the controller, and whatever signals are given to the controller or given by the controller, those are of control level. So control signals are you can say of electronic level, because mostly the controller could be a microcontroller or any electronic circuit made up of some op amps or like that. So obviously in this case, the power level of this control circuit is very low as compared to power level of the main, you can say, drive. So in that case, the power level of that power source or the converter motor, it could be few amps or could be few kiloamps, and even voltage is also very high. It could be few volts or few kilovolts, like that. So in this way, some uh, some standards are followed while drawing the diagram. So let's start with the first block, which is a power source. Obviously it is block diagram of electrical drive, so it should be a power source, electrical power source. So I'll explain this block in detail afterwards. So it is a power source. It gives power to power converter, which is the next block. Power converter is actually connected between motor and the power source. So obviously it has to uh, convert the power as per the availability of the supply and the motor. In short, it has to convert the power which is suitable to the motor. So if the source is AC, motor is DC, in that case power converter is obviously converting AC to DC. Or if it's suppose the power source is DC and motor is also DC, in that case the power converter may be controlling the voltage level, because the suppose power source voltage is of suppose 24 volts and motor is of 12 volts, or like that, or it needs a variable voltage between some 5 volts to 24 volts or like that. In that case it has to change the level of the voltage, and it also does some functions, some four functions, that also we'll see in detail afterwards. So power converter gives power suitable to the motor. So next block is motor. It is obviously an electrical motor. So choice of the motor depends upon the load and the various requirements of the load, and even working environment, and so many things are involved. So we'll be studying selection of the motor, or what are the, you can say, points to be considered while selecting the motor, how to calculate the power rating of the motor afterwards. So motor is actually converting this electrical energy into mechanical energy, which has to be given to the load. So load is obviously some mechanical, some physical thing which is meant for doing some work. So in our previous example, in fan, the blades were experiencing the load. So windage or opposition on those blades was actually load. It was invisible, but still some physical. Air is invisible, but still it is a physical load. Or sometimes suppose it is some pump. So pump is coupled to the motor, and pump is pumping water from one level to another level, or like that. Or it could be load, could be suppose some electric vehicle, some vehicle, or elevator. So to drive all those loads, motor has to give some motion according to the, you can say, requirement of the load. So it is not given, but the coupling between the motor and load is some physical coupling, and many times motor may not be running at the speed which is required by the load, because motors are available in standard sizes in the market, or many times the load is not matching, means load torque is not matching. So whatever is the required load torque by the load, so that may not be delivered by the motor. So there has to be some modulation done to the speed and the torque of the motor. If nothing is required, in that case the motor could be directly coupled to the load. Just in case of fan, the blades are directly connected to the rotating part of the fan, means rotor of the fan. So it is a direct coupling. And pumps are also directly coupled to the motor, but not many loads are directly coupled to the motor, because motors are available in standard size, and they are also having some standard values of speed, and you can say some other parameters also. So those are standard, and the load may not be suitable for that. So there could be some power transmission element between motor and the load. Example, some chain drive, some belt drive, or gears, and like that. So many times there is power transmission element between motor and the load. So this is these all four blocks, the upper four blocks consist of this power circuit, where the electrical power is available in, and you can say, huge amount. Okay, then comes the sensor. Sensor is actually sensing. Okay, so this part, so the sensor, controller and input command, so this is all you can say from that previous example. Human being is doing all that. So many times we need to control some parameter of the load. It could be, suppose, speed control, or some torque control, or maybe power control, anything like that. So if we have to do it, in that case we have to sense the parameter. Okay, this is like direct sensing the parameter. Sometimes the parameters may not be directly available, physical parameters may not be directly available for sensing. In that case, we may sense some parameter which can be used to calculate the required parameter. For example, flux in the machine, flux in the motor. Suppose we want to sense the or control the flux in the motor. In that case, we cannot mount flux sensors into the machine, because once it is manufactured, there is hardly a room to incorporate any sensor or anything in the motor, inside the motor. So that is actually not possible. So what can be done? Motor currents could be sensed, and from that the flux in the machine can be calculated, or in other words, it can be estimated, or in other words again, it can be observed. So observers you might have studied in control system. So those observers are doing such function. So it is some mathematical formula and some program in the controller, okay, which is used to calculate the required quantity. So some quantity has to be sensed or estimated or observed. Then that quantity, that actual output is given to the controller. Obviously, you might have studied obviously the measurement subject. So sensor and or transducer, what it does, it converts the physical signal into electrical signal. So it could be sensing speed or torque or anything like that, any physical quantity, machine temperature, anything. In that case, it is obviously converting it into some electrical signal. So input to the sensor is mechanical and output of the sensor is electrical, which could be very weak signal, because we know that every sensor use very weak signal, very small signal. Then we have to do some signal conditioning on that. We may have to amplify it. Sometimes there are some errors in the measurements, or some lacunas into the characteristic of the sensor. So some noise could be there in the measurement. So all that has to be filtered out by doing some signal conditioning. So sensor could be having signal conditioning unit inside it, or many times we may do it inside the controller. So sensor output is some electrical signal. It could be a weak electrical signal if there is no signal conditioning inside the sensor. Otherwise, it is some good amount of electrical signal, means like some standard voltage, 5 volts or like that, or less than 5 volts or like that. So sensor is giving some electrical signal which is proportional to the quantity to be controlled to the controller. Then there is input command to the controller. What is that input command? So input command is the required quantity which we are controlling. So in our previous example, the human being's comfort level was there set in his mind. It was the input command. I want this much comfort. So what brain does in that case, it senses the flow of air and it compares with the expected value or input command, and if there is some error, then control action can be taken. If there is no error, then no control action. So same thing, the controller compares the sensor output and input command, and then it produces some error signal. It could be a positive error, negative error, or zero error. So it depends whether the sensed value is higher than the input or lower than the input, or zero, or same as that of the input command. So likewise it senses, sometimes even signal conditioning is done inside the controller. So it senses the signal, compares the signal, produces the error, even processes the error, and then it gives a control command to the power converter. So we can see that controller is connected to the power controller, it is giving signals to the power controller. So this controller block could be some microcontroller, some DSP, digital signal processor, or some computer, or it could be some analog circuit like a PID controller. PID controller you might have studied. So proportional, integral, and derivative controller, PID controller. So it could be some analog circuit. So that is what the controller is. So in this way, the drive is actually a full system of all these parts. So many times the students are having a, you can say, impression that motor is a drive, but motor is not the drive. Motor is one part of the drive. It is just giving power to the load. But what about that? You can say the control part. What of the control part? Okay, motor can be, you can say, termed as a drive when there is nothing required, means no speed change, no torque change, or nothing is required. Just connect the motor directly to the load and give supply to it. So that system hardly we can say is a drive. Okay, so drive has to be some control feature has to be there. So only in that case it is some drive. Otherwise it is just a simple rigid system. So what's the point in studying in that system? So that is why don't consider only motor, okay, as a drive. So drive is the full system. So this is what the block diagram of drive. Just to briefly explain the other blocks. The first one is power converter. So here in the diagram it is shown that input power could be AC type or DC type, and motor could be of, okay, this is not about power supply, this is about power converter. So power source available could be AC DC, and motor type could be AC DC. Now DC supply can be given to AC motor as well as DC motor by suitably converted. AC supply also can be given to both type of motors, but accordingly we have to use the converter type. So first, the number one given is when DC source is available and DC motor is available. In that case both are DC. In that case SMPS or DC to DC converters can be used. Then second, DC source is available and AC motor is there. In that case inverters are to be used. Then if AC is available and DC motor is available, in that case we have to convert AC to DC. AC to DC converters are control rectifiers, so those are required. And then AC to AC, sometimes even supply is AC, but supply is of fixed frequency, fixed voltage, and motor could be run with some variable voltage, variable frequency. In that case it's number of cycles per second means frequency or the voltage level can be changed. So in that case, some cycloconverter or matrix converter, which is a new type of AC to AC converter, can be used. So this is what the power converter does. Okay, then there is power sources. So in India we have three phase AC, single phase AC. So that could be the power. Accordingly, that there could be voltage levels and current levels or power levels, we can say. So we know that low power drives are fed through single phase and higher power through three phase. So in our house there is single phase supply available. How much load we can put on that single phase supply, or what could be the maximum available single phase induction motor, maximum power of the motor? So hardly we can draw 15 amperes of current from the single phase outlet, because at the back end means the wire which is giving current to the home and like that, and if we go back like that towards the source side, in that case the system is designed according to those current levels. So 15 ampere, not more than that, we can draw from the single phase supply. So and voltage is also fixed, 230 volts and 15 amps. So you just calculate the power. So it could be around some 3 kilowatts or like that maximum. Now three phase supply. So when there is three phase supply, in that case mostly there is no limit on the current. That supply system is designed for high currents. Sometimes even the industrialist take some 33 kV line or directly 11 kV line into the industries if it is heavy industry, and they just convert the voltage levels and otherwise use as it is and like that. So this is AC available in India. Then there could be DC sources, so directly DC generator or sometimes solar or batteries. So batteries are having again standard voltages, or they are available in standard voltage levels, like right from some 6 volts up to 110 volts or like that. So we can convert any that we can connect the batteries in series and we can increase the voltage to any value. So according to requirements that can be connected. So there could be some DC sources like that, AC sources like that, and that is what the power sources is. Then the control unit. So controller is used to obtain desired response of the drive, and generally controllers are some microcontroller, microprocessors, or can say computers, some or electronic circuit. So generally ADICs, analog or digital IC circuit made of all this is control unit. So we have seen how it works, how what is the function of control unit. It handles low powers. Okay, then electrical motors. You know the type of the electrical motors. DC motors. In DC motor there are shunt, series, compound, and like that. In AC induction motors, squirrel cage motors, wound rotor motors. Then AC synchronous motors, there could be salient pole or smooth cylindrical type and like that. Then some special machines are also nowadays popular. brushless DC motor, BLDC, stepper motors, switch reluctance motors, SRMs. So these are also some motors to be controlled. So now, depending upon, you can say, requirement of the load, the motors are selected. Even as per the power level of the load, motors are selected, because every motor is delivering unique torque and speed, and even they are having some different capabilities. Some motors are fixed speed machines, and some machines are variable speed machines, and even there are differences in the ranges of the speed controls. So many things are, you can say, involved. Some motors can be electronically controlled easily. Some machines it is very difficult. For some machines, if we use some rheostats or something like that for controlling the power, then it is easy but not costly. It is very costly, or it is uneconomical. The power loss is very high. So like that, we have to consider so many parameters. Accordingly, we have to select the type of the motor. So in drives, we have to study this point very very clearly, because in whole these years, means years of engineering, you have studied so many things, means the knowledge is given to you. But now, as you are in the final year, or you can say this is applied subject, we have to use that knowledge which you have gained previously in this subject, and you have to apply the knowledge. So only studying the machines is not obviously enough. You must be able to use the proper machines at proper places, then do some maintenance of the machines, or do some troubleshooting of the machines, starting of the machines, controlling means braking of the machines, and all that you must do, obviously with the help of power electronic converters. So this this subject includes machines, knowledge of machines, knowledge of power electronics, knowledge of control system, sometimes knowledge of power system also. So it is like multidisciplinary subject. You must be master of all, like that, to design any drive. Okay, this is some point about motors. Earlier there were AC machines, uh, not very popular because they were very difficult to control. But nowadays they can be easily controlled. There are so many advanced methods available, and we know that from the construction and maintenance point of view, AC machines are far better than DC machines, motors. So that was the, you can say, issue. Okay, so we have come to end of this topic. So if you have any doubts, you can ask me later, and we stop here. Goodbye.